So proceeding to the next question, that is your question number 24. The energy levels for an atom are shown to scale. A photon of wavelength lambda is emitted because of the transition from E3 to E2. Okay, so an electron made a transition from your E3 to your E2, and corresponding to that a photon of wavelength lambda is emitted, right? So we know that delta E is equal to your h nu. Okay, now what is delta E? Delta E is the energy that is released when the electron makes a transition from your E3 energy state to your E2 energy state, right? So that means over here delta E is equal to your h nu, where nu is the frequency of the photon that is emitted. Okay, nu is the frequency. Okay, so the nu can be written as c by lambda. Okay, where c is the speed of light and lambda is the wavelength of the photon that is emitted. So delta E is nothing but your hc by lambda. Okay, so from here we get that lambda is equal to hc by delta E. See, over here hc is a constant. Okay, so from here I can write that lambda is actually inversely proportional to your delta E, right? So that means when delta E increases, what will happen to the wavelength of the photon that is emitted? Wavelength of the photon that is emitted will decrease, right? And when delta E decreases, what happens? The emitted photon will have a larger wavelength, right? So these are our two necessary conditions that you should keep in mind. Okay, now we need to find out which transition leads to the emission of the photon of a longer wavelength, right? So that means for a longer wavelength what should happen? So for a longer wavelength the energy difference should be less, right? And the wavelength should be longer than the transition from E3 to E2, right? So that means for longer wavelength we need what? Shorter energy difference, right? So that means the energy difference between the two states should be shorter than your E3 to E2. Okay, so that means the energy difference should be shorter than E3 to E2. Okay, so let us check the options. E4 to E1. See, over here E4 to E1 the energy difference is much larger than E3 to E2, right? So that means this transition will emit a photon of very short wavelength compared to E3 to E2. Okay, so that means this is your incorrect option. Okay, now check E4 to E3. See, E4 to E3 is actually, the transition is actually smaller than E3 to E2, right? So when the transition is smaller, that means the energy difference is smaller. What will happen? It will emit a photon of larger wavelength compared to E3 to E2, right? So that means this is the correct option. Okay, so let us explore E3 to E1. See, E3 to E1, okay, this is E3 to E1. So this is also having a much larger energy difference compared to your E3 to E2, right? You can compare this, right? So when you compare this, E3 to E1 has a much larger energy difference than E3 to E2. So that means the transition from E3 to E1 will emit a photon of much smaller wavelength compared to E3 to E2. So this is incorrect. Now proceeding on to the last option, that is your option number D, E2 to E1. See, the energy difference between E2 to E1 is also much larger than energy difference between E3 and E2, right? So that means what is the case? So this transition will emit a photon of much smaller wavelength compared to E3 to E2. So this option will be also incorrect. So that correct option to your question number 24 will be option number B.